In addition to helping us determine where the graph of a function is increasing and decreasing, the first derivative can help us find the relatively high points, called the relative maxima, and the relatively low points, called the relative minima of a graph. This helps us to graph a function, and these are called relative because they are higher and lower just relative to the points nearby, also called local max or min. They aren't necessarily the absolute highest or the absolute lowest points in the entire graph to be relative extrema. So for this first example, we're just going to label where the function is increasing and decreasing to make a conjecture about the type of extrema that it creates. So we're just going to do an exploration where we go in and we label these parts of the graph. So this first interval here, I'm going to say that it's increasing. It's rising left to right, so it would have a positive derivative there. It looks like then we switch to having a negative derivative on this interval. And then the last interval looks like it's positive as well for the derivative because it looks like it's back to rising. And then in between here, where we switch from a positive to a negative derivative, looks like it kind of stops at one point. That's where it's constant. The derivative looks like it would be 0 there. And then on this spot, where we're changed from a negative derivative to a positive derivative, looks like it had a point where the derivative would be 0, kind of had a soft peak constant part. So we could change all of this information into a sign chart where we label our critical numbers where the derivative is 0. So our first place where the derivative would be 0 would be at x is -1, so that's certainly going to be considered a critical number. And then my other place where the derivative looks like it's 0 is at a positive 1, at this soft peak here. So then before -1, it looks like I have a rising slope. So we have a positive first derivative there. So we're increasing. Between -1 and 1 is where the slope drops and it looks like it's falling left to right. So I'm going to put a negative here. And then after 1, we go back to having an increasing slope. Looks like it's rising left to right. So after -1 is a positive. Back to increasing. So this point right here, where I go from increasing to decreasing, I want to see, does this look like a relative max or a relative min? Is it higher than all the points around it or lower? And this happens to look higher. So I would consider this a relative max. So I'm going to label that in here. Relative max is what I get when I switch from having an increasing to a decreasing part of my function. I get a relative max. This next critical number, if I look at it on the graph, it looks lower than all the y values around it. So I'm going to consider that a relative min. And that relative min happens when I switch from a slope that is negative to a slope that goes to being positive. So our conjecture is that anytime we go from increasing to decreasing, we get a relative max, and decreasing to increasing is always going to yield a relative min. And we can kind of summarize that down here. Increasing to decreasing, increasing to decreasing is a relative max on our sign chart. That way we can do this without a picture. And then the other way around is when we have decreasing to increasing. When we go from falling to rising, kind of looks like a smiley face. Falling to rising, we get a relative min. This way we can find extrema without a graph. So let's do that again. Let's label what this looks like in here. So it looks like at first we are decreasing. We have kind of a constant part of our graph at x is 0. Then we go to decreasing again. We have a constant part of our graph when x is 3. And then we have an increasing slope. So we can put this in a sign chart. and just see if our conjecture above holds true again. So our critical numbers, where the derivative would be 0, would be at x is 0. We look like we're a constant part of the function. And our other place is at x is 3. Looks like we have a soft peak. So we'll label that in here. X is 3. Before x is 0, I am falling. Between x is 0 and 3, I am still falling on my graph. And then after x is 3, I am rising. So we go from a negative to a negative. But then we switch from a negative to a positive. So that negative to a positive should look like a relative min. And it does. That goes with our conjecture above here. Negative to positive, that point is definitely lower than all the points local to it or relative to it. But we haven't seen this yet. What happens when we don't have a sign change on our chart? We went from negative to a negative. Does this point look lower than all the points around it? No, it looks higher than the points on this side, but lower than the points on this side. So it's not higher than all the points around it or lower than all the points around it. We actually get neither a max or min. So I'm just going to label this neither. So that's kind of the last part of our conjectures. When you don't have a sign change, no sign change, say it's increasing to increasing or decreasing to decreasing, no sign change means there's no relative extrema there. Implies no relative max or min at that critical number, like we saw at x is 0, where we went from decreasing to decreasing, did not give us any relative extrema.